Greetings to all the grade 11s out there. We'll be doing mathematical literacy under scales and maps. So we'll be representing maps, plans, floor plans, house plans, and other representations of the physical world using scales. So before we go into the actual lesson, can we do some revision on what is a scale? Yes, a scale is a ratio, but what kind of a ratio? It is a ratio where one number represents another in the actual world, like in a map where a smaller number represents a bigger distance in the real world. What are the kind or the types of scales do we have? Yes, we have a number scale. We also do have a bar scale. So I have made a summary of all the things we have been discussing. We know that, let us just read the definition, the actual definition of what is a scale. It is a ratio between the distance measured on a map, measured on a plane, or measured on a model, and the actual distance in reality. So we'll be using a number scale. We'll be working with number scales and bar scales. There are also verbal scales, which are actually a number scale read out loud. So it is not that important. So the two important types of scales, it is the number scale and the bar scale. So I have made a summary for you so that we can summarize everything we have discussed. The type of scales we'll be working with number scale and bar scale. So in the number scale, when we represent a scale, they must have the same units. For example, 1 is to 1 centimeter is to 50,000 meters. We must turn the 1 centimeter into meters, or convert 50,000 meters to centimeters. So in this case, we converted the 50,000 meters to centimeters by multiplying 50,000 meters by 100. Then we can represent it as 1 is to 5 million centimeters. Now we can actually represent it properly as a number scale. But a number scale, it won't be helpful. We won't be able to use it if a map or a plane is enlarged or reduced. That is why it is said number scales become invalid if the map is enlarged or reduced. So the mostly used scale, it is a bar scale. So a bar scale will be doing a lot of measurements. In bar scale, it is commonly used because it becomes accurate even when the map are reduced or enlarged. So the applications of scale in the real world are mostly on maps and plans, floor plans, house plans. So before we go to the actual lesson of today, can you do some revision on metric measurements? Please, we must be knowing this. We must be knowing because we'll be converting a lot, especially when we are working with number scales. So we know that 1 kilometer equals to 1,000 meters, because we know that kilo means 1,000, and 1 kilometers is 100,000 centimeters. 1 kilometers, it's 1 million millimeters. 1 centimeter equals to 10 millimeters. So now we are done with that. Can you go to the actual lesson of today? So I would like us to communicate together as we engage in this lesson together. So firstly, I would like everyone to draw this bar scale before we go to the worked examples. Can you draw this bar scale? Can you measure from 0 to 2 kilometers? Can you measure 4 centimeters? Meaning that 1 kilometer will be represented by 2 centimeters. So I will give you time to finish that up. So when you are done drawing the bar scale, can you please measure A 5 centimeters and B 8 centimeters, so that we'll be able to answer this question. That reads, use the bar graph to determine the real lengths of the following lines which represent distances on a map. For the first line, which measures 5 centimeters, the answer must be in kilometers. The second, which measures 8 centimeters, the answer must be in centimeters. So for the first question, we know that from the bar scale, we know that 2 centimeters represents 1 kilometers. This, it is not right to write it like this, because we know that the units must be on the same metric unit. But we are just writing this so that we can be able to convert 5 centimeters into kilometers, what it represents in the real world. So we multiply both sides by 5 centimeters and divide by 2. Then on the left hand side we are left with 5 centimeters, which will represent, when you use our calculator, 2.5 kilometers. So we are going to do the same thing on the second question, on the line of 8 kilometers. So from the representation, what must we multiply 2 with so that we get 8 centimeters? We must multiply 2 with 4 centimeters and divide by both sides by 1 centimeters. And on the right hand side, we multiplied by 4 centimeters, divide by 1. So 8 centimeters in the real world will represent 4 kilometers. Then using the metric measurements that we passed through, we multiply both sides. We multiply this kilometers with 100,000 so that it is converted to centimeters. So 8 centimeters represents 400,000 centimeters. So that's how we'll be working with bar scales. So can we go to number scales now and see what will... It is very similar but quite... So working with number scale, let us read out the question. The distance between two buildings in a town on a map measures 4.8 centimeter on a 1 to 20,000 map. What is the distance on the ground? So we are given a scale, we are given a distance, so we want to know what does that distance represent in real life. So we know that 1 centimeter represent 20,000 centimeter on the map. If that's the case, we will multiply the 4.8 with 20,000, which gives us 96,000 centimeter. So 4.8 centimeter on a map represent 96,000 centimeter in real life. And that's it for today. We have covered all the work. So I will send you guys the worksheet and you will send it to me and we'll continue from here. Thank you.